Hey everyone, I'm Stéfany Coura Coimbra. I'm a student of computer engineering at University Itajubá, and I made the TinyML course on my previous semester with the Professor Marcel. And me and my group built a project called COVID-19 Detection by Cough. I'm presented this project today, and so let's do this. What are the goals? Why bring this matter to a project? Well, we see more and more people in hospitals, and the statistics of this pandemic, it's not good. And family, friends passing through difficult moments, and we're all in this situation, right? So it's important to think on new ways, new solutions to win these obstacles from the situation. But let me just clarify a very important thing about this project. And the purpose of it and the motto is to only assist on diagnosis, helping people to identify the disease, but doesn't replace, under no circumstances, the medical diagnosis. So it's a research, and the purpose is to education. But what is the main idea? Oh, the project is to identify if a person has COVID-19 or not. And okay, but why use cough to detect COVID-19? Because with that, we can detect asymptomatic people by cough characteristics, and we can use that of our non-invasive form of detection instead of the tests, the pre-tests that it's uncomfortable, and with that we can identify like a pre-diagnosis if a person has the chance to have COVID-19. But we have a lot of difficult moments. For example, we have different types of cough. We have dry cough, wet cough, cough related to COVID-19, and we have another difficult, that is the data set. The data set has another sampling rate that is of 48 kilohertz, and we need 16 kilohertz because we have to deploy it on the Arduino BL eSense. That's the purpose on the final step. And another problem is the silence and another sound beyond cough. It's together. So we have to split and we have to separate these. But let me show you how difficult it is to identify if a cough it's wet, dry, or related to COVID-19. Are you ready? Let's do this. So it's difficult, right? The first one, it's related to a dry cough. The second one, it's related to COVID-19. And the third one, it's a wet cough. But it's difficult, so our ears identify that. And could be a problem to the model too. Let me show you why. The dry cough has less energy in the intermediate phase. The wet cough, on the contrary, has more energy in the intermediate phase. See, the lines, the parallel lines on the dry cough, it's on the final of the image, and these lines on the wet cough, it's more for the middle. And here is a comparison. The COVID-19, it's similar to dry coughs in their first stage, and then looks like more wet coughs. So it's a big challenge to us identify if a person has COVID because of that. We don't know the cough is in the intermediate phase or not, and that could confuse the model because could be just a dry cough or COVID-19. But how was approached the problem? Well, we first collect the data, then we have to process the data because of all of these issues, and then we have to apply future engineering and train the model, and the final step is to deploy. And this is what we have to do later. And in the training step, we have to obtain the data, then pre-process using a filter, then train model, evaluate, checking the accuracy, and later deploy. To pre-process the data, we use an extractor. We have to downsample all the audios to the 16 kilohertz. That is the frequency of the microphone on Arduino BL eSense. And we also have an issue related to the format of the audios, because we don't have audios in the dot waveform, so we have to change the format of the audios too. And we did that with this function in Python, using Jupyter Notebook and also Google Colab. To collect data, we use the public dataset called COVID crowdsourcing, and has 237 samples of COVID-19 and 837 samples of healthy audios. Then we have to extract all the spectral features, reduce the size, and convert the audio to a ML frequency scale using MFCC. We do that too to change of a time series to an image, so we can use convolution networks. Then we have this occurrence here, the training model, when we trained the model, and after many tests, we got 92.5%. That's good, but that's with data that the model knows. And this is the incorrect predictions in this stage. But when we put in the model data that it don't know, the occurrence drops to 47.84%. And that's a problem, because we don't want that. We want more than 80% at least. So the next steps. We can try to use anomaly detection using silence as an anomaly detection. We can extract from the audios only the coughs, and we can use types of combinations in the ML, like change the number of layers, neurons, and learning rate. And then only then we deploy on Arduino BL eSense. So about the next steps, we can use silence removal to return segment endpoints that correspond to individual audio events, removing silent, using a Python library. And doing that, I got 706 samples of COVID-19 and 706 samples of healthy audios, but doesn't change the general result of the accuracy. We have yet a lower accuracy when the models saw a new data. So we have here the references that we use to build the project until here, but we plan to continue with the next steps that I showed to you. And here we have the data acquisition. So we uploaded all the data and split training data and test data. So the impulse that we created, we have here the window size, and we use MFCC here, as I said, and the rest of the characteristics, it's normal. In the MFCC, we have the number of coefficients that we test with the pattern 13, and we change to 40 and works best. And we can see how the COVID-19 and healthy data it's related. And we have the classifier then. The classifier we made with 3 convolution layers, 1D, because 2D consumes more memory, and we don't want that, and 1D works good. So we use the dropout. The 20% of the neurons are off, and this after each convolutional layer. And here, what I'm talking about, the accuracy in the training, it's good, but when we skip for the model testing and look, the accuracy drops off, and in the next steps, we plan to fix these problems. And I'd like to thank you for the opportunity to present this project. And if you have a suggestion or want to collaborate with the project, just send an email to coviddetection@gmail.com. Thank you so much.